So today's going to be our last class for this session. So yeah. Okay, so I'm going to start. So this week's topic is transformation and geometric visualization. So let me share my screen. Okay, so first I want to go over a few types of transformations. So the first one is rotation, which means turning something around a center. So here you see the arrows over here, and then in this image it rotates around this center to go to another place. And the distance from the center is going to stay the same. And then the next one is reflection, and reflection is a transformation that creates a mirror image. So, for example, over here on the left is the original shape, and then it reflects to the other side, and then it turns into this. And then lastly, there's translation. So translation is just when you like move a shape from its original place to another place. So here, this triangle is translated right to over here. So now I'm going to go over some types coordinate transformations, which is transforming points on a coordinate plane. So the first one is going to be just transforming a point across the x-axis. So I'm going to use Desmos here. So this is a graphing website. It's really helpful. So you can put in like points in here and graphs, but I'm just gonna like write everything. So let's say there's a point, just choose a random point here. Let's say 4, 3. Then this would be the point. If you translate it across the x-axis, this here, this axis over here, this is the x-axis. And you translate across, you would get here. And the formula for this over here, you have the point x, y, and if you translate across that x-axis, it will become x negative y. So here the x stays the same, it's still 4, but then the y-axis changes from 3 to negative 3. And then I'll go over the second example. So next one is over the y-axis. So the y-axis is the vertical axis here. So how this works is you have a point xy, and you just and then it turns into negative xy. So I'm going to use the same example. So 4, 3. So translate across the y-axis, the y coordinate stays the same, and the x coordinate becomes negative. So here, this x coordinate is 4, so negative 4, so it'll be negative 4, 3. So that will be the reflection of that point over the y-axis. And then next one is over the line x equals a. So let's say there's a line x, let's put x equals 2 as the example. So this is pretty intuitive, but there's also formulas and it's also intuitive, so I'm going to show both ways. So just going to draw a line from x equals 2. So yeah, there. So then that line over there is x equals, oh wait, no, oops, that's y equals 2. Sorry. Make it vertical. Yeah. So that is going to be x equals 2. So then next we're going to keep the same point. So 4, 3. So if you translate across, you see this is 2 units away from x equals 2. So that means the reflected point will be 2 units away on the other direction from this line, because they're both the same amount away. And here there's a formula you can use. So here's 2a minus x. So you have the point xy and it turns into 2a minus x and y. So the y coordinate will stay the same. So the y coordinate will still be 3. And
Wait, I have a question.
yeah.
So like what you talked about, can you explain like that line thing again?
Okay, so here I want to be explaining this one, C. Oh, the transformation is transforming a point across a line. And in this case, the line is x equals a, and in this specific case, this line is x equals 2. So I'm just showing how to like translate a point from over here to the other side of it. So
What is the formula about?
okay, I'm gonna explain it now. So in this situation, a equals 2. So that means, so in this situation, we're just going to put in the variables here. So we'll have x will equal 4, y will equal 3, and a equals 2. So if you just plug it in into this equation, you'll have 0, 3 as the answer. And if we look at our graph here, it is the same.
Wait, so it's like if a equals 2, then 2 times 2 equals 4, and 4 minus 2 equals, isn't that 2?
The x coordinate is 4, not 2.
Oh, okay.
Okay, and the same thing basically applies to the y coordinate. So here it's just going to be y equals 2. So we want to keep the same coordinate. So 4, 3. You flip it over, it's 1 away from this line. It would be 1, 4. And if you look over here, we can plug it in. So x, hold on. I'm at 4, 1 here. Okay, so if we look at this, the x is 4. 2a minus y would be 2 times 2 minus 3, which is 1. So, yeah. Okay, so the next one, it's, let me clear this. Next one is across the line y equals x. So, I actually want to put in the equations here. So here we have for 3. What you do is you just reflect across this line to here, which is the coordinate here is 3, 4. And here how you do this is you have the coordinate x, y, it becomes y, x. So you just flip it. And then the next one, y equals negative x. So I'm just flip this. This is very similar. You just look at it and it would be over here because it's 4 over and 3 down. So for the formula for this, it would be the point xy, it would become negative 1, negative y, negative x. Yeah. And then the next case is y equals x plus m. So let's say m is equal to 2. So y equals x plus 2. So 4, 3. So if you look at this equation here, it's y minus m and x plus m. So y minus m, y minus m is 3 minus 2, which equals 1. So, and then x minus x plus m is 6. So it would be 1, 6 over here. Oh wait, no. 1, 6. And then there's another similar one, y equals negative x plus n. So in this case, n is going to be a 2 again. Point is 4, 3. So here's n minus y and n minus x. So and here 4 minus 4, 2 minus 3 is negative 1, and 2 minus 4 is negative 2, negative 1, negative 2, it would be here. So the last one is going to be reflecting a point over another point. So I'm just going to put in this point here. We reflect this over. So this is technically just reflecting it over the x coordinate of this and then the y coordinate. So how we do this? Basically, the equation for this is very similar to the equation for C and D. So I'm gonna write the formula here. To b minus y. So a is 2, x is 4, and then we'll have this first coordinate be 0. 2b minus y, b is 1, so 2 1 is 3, is -1. So there it is.
Can you give some examples?
Well, which one?
Like other than the one you just did about 2a minus x and 2b minus y.
So I'm going to actually give a few problems which apply to these examples. So I'm going to actually do them. So these problems will use the examples I just showed. So the first one, the point 5, 3 is reflected about the line x equals 2. The image point is then reflected about the line y equals 2. The resulting point is AB. Compute A plus B. So you can try it and then send your answer to me.
Am I correct?
No, you try again, but you're pretty close. Okay, so I got a few right answers. I'm gonna explain this problem now. So
Can I oh, I get it now. So I only did the x equals 2 thing.
and so here is, I'm gonna scroll up so you guys can see the formula here. So first, it's gonna reflect across line x equals 2, which is this, just C. So 2 times 2 minus 5, 3 equals -1.
Wait, is it 0?
Yeah,
Okay.
and the next case is you reflect this across the line y equals 2. So x -1, 2 times 3. Wait, no. Two times, oh wait. Two times 2 minus 3, which equals -1, 1. So this will be our final answer. So -1 plus 1 equals 0. Okay, so the next one, the point 2, 3, and 5 1 are reflected across the y-axis. Find the number of gradients in the area of the quadrilateral whose vertices are the points in their images. So you can try it and then I'll explain it later. Just send your answers to me when you're done. I can check.
Wait, can you give me a graph for this? Because, or do I have to graph it?
You can graph it. It would be easier to see it and do it if you graph it.
So I'm supposed to find the area of the trapezoid?
Yeah. So I want to explain it now. So
Is it 20? Oh, okay.
so it's going to be kind of hard to graph it. Alright, so I'm just going to actually graph on Desmos. So 2 points we have are 2, 3. Two, 3, and 5, 1. And then over here, we'll flip it across. It will be -5, 1, and -2, 3. So how this works is you can tell here that it's a trapezoid because these two, if we collect the lines, this over here is the two bottom and the two top lines are parallel. So how the area of a trapezoid is the two bases add together times the height divided by 2. So the height here is, this is the coordinate over here is 1. The coordinate over here is 3.
28.
What?
Is it 28?
No. So wait, so if this is 1 and this is 3, then that means the height is 2. And then the base over here, it's -5, 5. Over here, it's -3. Or no. -2, -2. I mean, +2. So this length over here is 4. This length over here is 10. So it'll be 4 plus 10 times the height, which is 2, divided by 2, which is 4.
Wait, why is the height 2?
Because the y coordinate of this bottom point of this bottom line, so this line over here is y equals 1. This top line here is y equals 3. So 3 minus 1 is 2.
Okay.
Okay, so the last question is a bit hard, but I never really specifically taught this, but it should be doable. So the graph of the parabola y equals x squared minus 2 is reflected with respect to the line y equals -x. Write the equation of the resulting graph. So yeah, I got a right answer already. Oh wait, oops.
For the equation, I only saw one for like the point. So am I supposed to turn everything in here negative?
I'm actually going to explain it because it's a bit different than what I explained before. So we want to reflect it across the line y equals negative x. So how we can actually do this is we can plug in y for negative x and negative x for y. So how we do this is y equals x squared minus 2. So we'll put in negative x for y. So this turns into negative x equals y. You know. Negative y equals x. So here we have negative x equals negative y squared minus 2. And if you, oh wait, hold on. Sorry, the power is outside of the parentheses. You'll have negative x equals y squared minus 2. And if we rearrange this, we can get x plus y squared equals 2. Okay, so the next section is going to be geometric object transformation. So first, that's going to be a really quick review. How many of the 18 pentominoes pictured below have at least one line of symmetry? So we can test all of them and just see which ones of them have lines of symmetry. So tell me how many there are and which ones they are. So just label them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So just tell me how many there are and which numbers, which ones they are.
Wait, what do you mean by symmetry? Does it like one figure has how many symmetries and stuff?
So I'm going to just show one example. So we can try the first one here. So this one is actually a case because you see here, it has a line of symmetry right here. Not that accurate. But if you flip the top onto this line, it will match with the bottom line.
So this one only has one symmetry? Or can we split it in half from top to bottom?
Yeah, but it only needs at least one line of symmetry, so this counts as a case.
I still don't really get it. Like the rest I see don't really have a symmetry at all.
Well, you can just check all of them. I'll actually tell you how many there are. There's 6. So
Wait.
just find which 6 are symmetrical.
So number 2 and 3, are they like 1 or do I count them as 2?
They're 2 separate ones.
Okay. I found all of them that have a line of symmetry. So should I?
You can send them in the chat.
Okay, I like to you privately.
Yeah. Yeah, Studio, can you tell me which ones have a line of symmetry, just like the numbers of them?
I accidentally wrote a typo. It's not 15.
Yeah. You're
It was 14.
yeah. Gotcha.
So can I say all of them?
Sure.
So there are 1, 10, 11, 12, 13, and 14. That's what I got. That's why there's 6.
Yeah, so I'm just gonna show how all of those have symmetry. So the first one I already showed it. That line across, and there can also be a vertical line. Then 10.
2, 3, 4, 5, and 6, 7, 8, 9, and 15, 16, 17, 18 don't work.
Yeah, so
Oh, 11 can split it from top to bottom. In number 12, you can split it diagonally. Yeah, and then you split it diagonally from the left top diagonal and to the bottom right diagonal. And same as 12 and 13 and 14 could be diagonals or like straight lines from like top to bottom or left to right.
yeah, so good. Oh yeah, it's 14.
So there are like
It actually has like a lot of lines of symmetry.
But
So
yeah.
yeah,
In this case, we just need to find if they have one line of symmetry, since like the question's asking how many have one line.
okay, so good job everyone. So I'm gonna go on to the next one. Square ABCD is rotating 90 degrees clockwise about its center and reflected over a diagonal line determined by lower left and upper right vertices. The square is then reflected over a horizontal line through its center. What point now corresponds to the position originally occupied by B? So this one you should do it step by step.
I don't really get it.
Alright, so do you want me to explain it now or does anyone else want to try first?
I want to draw it on my whiteboard.
Yeah, drawing it would help a lot.
What do you mean by a diagonal line determined by lower left and upper right vertices?
So let's say
I think it means a diagonal line from like what I drew from B to D.
so the lower left is here and the upper right is here, so you just reflect it.
But like once you turn it 90 degrees clockwise, it becomes sort of like a rhombus.
No, so actually I want to explain this because I think you guys are getting pretty confused.
No, I think when it turns, it becomes A and C.
So here,
It's occupied by nothing. You have 90 degrees and you move until you have like a tilted rhombus-like square. 90 degrees is still square, right? Yes, it's still a square, but it's not like 90 degrees all perpendicular stuff to a horizontal line.
when you actually rotate it 90 degrees, it becomes another square, just rotated. So here I want to flip it. So you rotate it 90 degrees. A will go here. B will go here. And C and D. And then next, you have to reflect it over diagonal, which is here. So,
and then you'll have B at the top and D at the bottom.
yeah, so A and D will stay the same, but B and D will switch.
Wait, no, I don't get it.
Okay, so
Well, A be at the bottom?
no, because the diagonal is from C to A, and you only want to flip this across.
Like, how do you know you have to flip it to the wait. Wait, so like, do you mean by what point now corresponds to position originally occupied by B? Does it mean like what point is at what in?
So originally B was here. So what point will be in this position now?
A.
No, I'm not done with yet. So this is after the diagonal step. So then the last step is you have to reflect across a horizontal line. So this, all of them flip over. So we'll have over here.
So it's D, C, and D itself. Oh. So I guess it's D this time.
Yeah, so it is D. And I'm actually not going to do this question because it's a bit confusing. And so I'm going to actually skip that one. So the next one is going to be geometric visualization. So first, I'm going to talk about like some three-dimensional objects. So the front, top, and side views of it. So first, this is going to be good practice. So draw the front, top, and side views of this figure. So actually, I want to explain it right now because it might be a bit confusing. So the front view is just going to be this pattern right here. So
the front view is like that curvy thing.
the front view is going to be this. It's not a great drawing, but you see how.
And then the back view is just flipped, like not flipped, but like
It's basically the same thing.
Opposite of the front view. Yeah.
And then the next is going to be the
three is on the 3 blocks on the left side. Side view towards the right is only that 3-unit square thing, and the left side view is also the 3-unit thing. And looking at the top and the bottom, you also get 3 units.
So at the top, you'll see these three. So the top.
And at the bottom, you just see the bottom 3 blocks.
Yeah, so the top view and the bottom view are the same. And both side views are the same. Over here on the side, there's one over here, one over here.
And the side, like to the right, is like 3 blocks, and then to the left is 2 blocks. No,
actually, it would be 3 blocks because.
To the left, you only have. Oh yeah, because like, and when you turn it, the topper one is also like looks like the one on the left. So they're both 3, yeah.
Yeah. So the next one, 6 cubes, each an inch on an edge, are fastened together as shown. Find the total surface area in square inches. Include the top, bottom, and sides.
I have a question.
Yeah.
So towards the north from the middle block, is there a block exceeding that? I mean, no, because if you count it yourself, then there'll be like 7 cubes, but like there's only 6 cubes. So like the bottom is basically yeah. Like, let's see. And we have for the front view, it would be this It'll be like something like this. Okay, we can't annotate though, but it looks something like annotation that you can. I already this. How do you draw it? Okay, I can't draw it, but you go and draw it. So it's that that 5 block thing with 3 blocks in the middle and 1 block in the middle towards the right and 1 block at the bottom towards the left. If you get what I mean. And then like for the top, there are like basically like 3 blocks. The bottom, there's 4 blocks, I think, or something. But I don't know. There are. Irene, I don't think the top only consists of 3 blocks. Or maybe it can consist 4. Like, but I don't get it. You can't actually. Wait. Can I say what I think it is? So I said what the front view is. The back view is the same, and the top view is going to have like a horizontal 3 blocks with 1 block at the very left jutting out to the bottom, and then for the side view, it's going to be for the side view of the right, it's going to be a vertical 3 blocks with 1 block at the bottom jutting out to the left, and then the side view of the left will be the opposite of what is on the right, and the bottom view is going to be sort of like a W shape, but with 1 block at the very corner.
Yeah. So
wait, isn't the top view supposed to be like look like 3 blocks? Because I feel like the top view is like 3 blocks, and then the bottom view is like 4 blocks. But
the top view and the bottom view are the same.
Yes, there are 4 blocks. I don't get how you find like 4 blocks on the top.
Wait, no. So the front and back view each have 6 blocks. The top view has 3. The top and bottom views have 3 blocks, and the side views have 3 blocks.
So then it's like 4 plus 4 plus 3 plus 3. Okay, I don't know. Okay, like for this. So then, like for top and bottom, they're like 4 blocks, but then like for the sides, they're like all 3 blocks. And then for like the front, it looks like the side 5 blocks, and in the back, it looks like the side also has 4 blocks. It doesn't just. Oh yeah, because there's one next to the the one that's vertical. So yeah, the sides also has 4 blocks, I guess.
Okay, so can we move on to the next one? Because we're kind of running out of time. So 6 cubes, each an inch and an edge of sides of the direction. Find the total surface area in square inches. Prove the top, bottom, and side. So I'm actually going to just explain it because there's only like 7 minutes left. So here, find the total surface area. So like I said before, the top and the bottom are the same. The 2 sides are the same. And the front and the back are the same. So here, the front, we see.
There's 5 blocks because there's 1 block sticking out from, there's 5 blocks.
Yes.
In the front. And in the back, there's also 5 blocks.
Yes, so 5. And then the side, there's
also, there's 4 because, there's 4.
And then the top.
There is 4, I think.
Yeah, and since I would have to multiply this by 2 because the back, side, and the top.
Oh, yeah.
The side and the bottom are.
So then that will be 13 times 2, which is 26.
Yeah.
So there are 20. The opposite sides of the two opposite sides for this figure will always have the same number of block faces.
Yeah. So next question. The drawing board below is a base plan of a solid figure made of stack cubes. Which of the following solid figures is represented by the base plan above? So the numbers here mean how much is stacked top. So for example, so I'm gonna just go through each of them and see. So this is A. So it looks the same. The base is the same. So then
I don't get how the base is the same. The problem for number A is that the second row does not have 3 blocks. Instead, it has 2 blocks. No, in the second row, it has 3 blocks. But I'm talking about the height. Then yeah.
Yeah, so for this one, let's say here, this row, it has to have 3 blocks because here there's 3. So this one will want to be the answer. And how you do this is basically just go through all of them. And when you look at B, you see here, this one, it's 2.
I don't really get the base plan.
All right, so the base plan is going to be what the shape of it is going to be the shape of the bottom. So for example, B matches the base plan. There's 2, the 1 here and 1 here. But C doesn't because there's 1 here, even though there's supposed to be 2 here.
Yeah, so I think B is the answer.
Yes, because if you see how tall the blocks are, they match with the base plan.
But I still don't really get the base plan.
All right, so I'm going to explain it. So there's 2 things. The first thing is the shape of it, and the second thing is the numbers. So the numbers represent how tall it stacks. So for example, I'm going to just draw the base plan of E over here. So oh wait. I said ignore that random thing, just ignore this one. So this is going to be the base plan of E. These, if you look here, there's 1 here, 2 here, and 1 here. And the next thing is the numbers.
I don't get the numbers, which are 4, 4, 3, 2. What do they mean?
Okay, so 4 means how many blocks high this is. So for E, this first one, this block here, it is only 1 block. So it'd be 1. And over here, this block here, it's also only 1. And the one over here is also only 1. But let's say this one. This is 2 blocks high. So this one would be 2. This one also would be 2. And you just see how tall they stack.
So that doesn't match the base plan, so it can't be. You can see from the base plan that it is different from the one at the top. Okay, I guess I have to do. It's really confusing. Sorry. No, first I'll look at the base, because you can just do A, B. You can literally cross out B, D, E, because if you look at the 2, it definitely doesn't match the base plan.
Yeah.
So that it has to be like A, B, or C, but
Actually, it wouldn't be.
It wouldn't be C, actually. It wouldn't be C. It wouldn't be C.
So A or B. So now here it just depends on the numbers. So this is going to be the first part. So over here, they both have 1 block. And then this here, it says 1. And then here,
it only
the next one next to it, this is 1. But over here, this is stacked 2 blocks high.
Yeah, but
That
you need you need 2 blocks high, so it has to be.
Yes. So the last thing I'm going to cover is nets. So nets is like a piece of paper and you just fold it into a geometrical shape.
Oh.
So let's say you have a normal piece of paper. So here, you can't really fold this into a cube. But if you cut it in a specific way, then you can. So you just have to visualize.
Oh, so like a cube contains a T-shaped thing with like sides. So like, so then like when you fold it.
Yeah. So,
I think I already figured out the first one. I feel like the first one is cube.
Yes. So the first one, it forms a cube. You have to see which face is opposite of the white.
So like the opposite. Let me think. I want to look. So I think the opposite of the white face is blue. I think it's blue. The B. Yes, it's blue. Because think about it. Because if you fold it, the red would be on the left side, the green would be on the bottom, the blue would be on the back, the white would be in the front, the yellow would be on the right side, and the O, which is the orange, would be on the top.
Yes.
You see, that is why it is blue, because you can tell when you imagine it's folded that blue would be the opposite of white. Just imagine that you're folding the cube in your mind, and then you figure out what is the opposite of what. Which is blue. I wish the B stands for black.
Yeah, okay, so that one was pretty easy. If you just imagine you're folding it, you'll see that the opposite of white will be blue. So the next one is another example of a net.
I still feel like this one's still a cube.
Yeah.
And it is cube.
So which 4 faces are adjacent to the one labeled?
So 5. What does it mean by which 4 faces are adjacent? Charlotte, is it 5? I don't get this. I don't get what 4 faces adjacent to one labeled to one. I think 5 is the opposite of 1. Yeah, 5 is the opposite of 1, but like, what does 4 faces adjacent to the one labeled with 1 mean?
It means the faces that are next to the
one. Oh, then let me think. It would be 1, 2, 3, 4, 5.
Actually no. So basically this will be all the
1, 2, 3, 5
are going to be all the faces except for the one that is opposite to it and that face.
Wait, I don't get it. Like, because the 1 would be on the top, the 2 would be on the left side, the 4 would be on the right side, the 3 will be in the back, the 6 will be in the front, and the 2 will be like on the right side. Okay, I don't know how to explain it. Wait, did we move on to number 3?
No. So
like if you kind of look at a little, like if you imagine and look at it, it actually looks like 3, 4, 5, 6, like half of a box.
So wait, so I'm gonna explain it. So if you see this, you'll see that 1 is going to be on the top. Let's put 1 on the top, and then if you imagine folding it, that means 5 will be on the bottom.
Yeah, and then what
4, 6, and 2 are adjacent to the face that is labeled.
I put 1 on the side. No, I cut 1 on the top.
Both ways work.
When I fold it, I think that 1 on the side is more easy for me. I feel like 1's on the top. Cause, well, that I guess you can use. I guess it's wrong, but there's no.
They both work. Okay, so now you'll just see that 5 is opposite, so 5 can't be adjacent to 1. That means the 4 that are adjacent are 2, 3, 4, and 6. It asks for the product of them. So if you multiply them, you should get...
I don't know. It equals to 24 times 6. No. It equals to 6. 24 times 6. Yeah.
So that equals 144.
Which equals to 144. So the answer is 144.
Okay, so the last thing is going to be a different type of math.
I have a question. Like, are you gonna use 1 times 2?
What?
Okay, whatever.
Okay,
So let's see. I think fix on the bottom. Wow, this one's confusing.
you just have to get used to.
Oh, I feel like it's something with the triangle. No, it does not go with a triangle. Or it can be something else, yeah, but I don't know. And it can. Okay, this is hard. There's so many triangles. So like that sides that share a side with number 1, we know that 4 and 2 obviously share a side with number 1. So we can keep that in mind. And then if we fold it, then we can have like, I don't know how you can fold it. 2, we know 5 doesn't work, and nor does 6. 6. Wait, is 6 on the bottom?
Wait, which question are you guys doing?
Number 3.
Yeah, so number 3, I just want to show what it should look like. So
Show us. We're so confused.
An octahedron. So this image here.
What? It's an octahedron thingy.
So this image here is an octahedron. There's like a square pyramid on the top with 4. And the bottom there's also 4 triangles.
Oh, so those things. Okay, then I don't know what it will be though.
So first we have to find the bottom pyramid thing. So that would actually be 6, 7, 8, and 5. And you can form a square pyramid with those.
I'm counting on you. I have no idea.
And then 1, 2, and 3, and 4 can form the top half. So there's going to be 4 edges that no, there's going to be 3
what I'm thinking is that number 2 and 4 will always be on number 1, and then if we try folding it, I think 7 will also be, but 6 and 5 won't. Yes, 7 would be on it. So 2 plus 7. But then I think it's 2 plus 7 plus 4. 2 plus 7.
Close. So it's actually okay, so 2 and 4.
I think it's 2 plus 4 plus 7.
Right, so 2 and 4, right? But it's actually going to be 8 because.
Oh, I get it. Because 7 is with 2.
Yeah. So it'll be 8. You add it, and you'll get 14.
Cool. So the answer is 14.
Mm-hmm. So
if we add a 7, the answer will be 13. Phew. Is there going to be a forms this time?
What?
Is there a forms this time for homework? Because I don't think I see a homework sheet on this.
I'm gonna post I'm gonna put the questions for the homework on the Google form.
So is it going to be Google Forms?